In 3D Experience, there are 11 steps to performing a physics simulation for a single part. Starting with a design model, we will take you through the first 4 steps associated with creating a simulation model. We will use the slotted lug component from a trailer hitch assembly. In the video, Basics of Element Selection, we showed you the logic behind designing the mesh for this component. In this video, we will show the exact steps to creating this model in 3D Experience. The hitch must support a 2,500 Newton hitch load and a 26 kilonewton pulling load. We need to decide how we are going to restrain and load the slotted lug component. First, let's remove the lock pin. We are going to replace the pin contact with the restraint acting in the X and Z directions. This will require us to create some geometry that we can use to create a group of nodes. We will also want to make sure the mesh follows this edge. The loads are transmitted through the center of the ball. So, we will create a point at this location. We can use this point to apply a remote force. We also need to create a surface where the ball contacts the lug. We will use this surface to transmit the hitch and pull loads applied at the center of the ball to the lug. We will replace the contact between the lug and the adjustment bar with a restraint in the X direction. We don't need to create any additional geometry to do this. But we will create a publication. Let's get started with step 1. We will create an abstraction shape. An abstraction shape is a container into which we place a dependent copy of the part's original geometry. We right-click on the slotted lug part and select Insert Abstraction Shape. Then, we edit the properties and change the name to FEA lug shape, and click OK. Now, we will copy the design model and paste it into the abstraction shape. We double-click on the 3D shape. Then, we right-click on the part body and select Copy. After double-clicking on the abstraction shape, we paste the dependent copy of the design geometry into it. Some apps expect the copy geometry to be in the part body container. So, we move the copy geometry from body 2 to the part body container. We no longer need body 2, so we can delete it now. We can now start preparing our simulation geometry. We make sure the part body, in the abstraction shape, is the in-work object. This will place features we create in this part body. We load the simulation model prep app and select Defeaturing from the action bar. All of the features on the lug are critical, so we will not launch the app. However, it is important to know where this app is located. We are now ready for step 2. The first thing we need to do is create some geometry to apply the X and Z restraints to the pinhole. Within the structural scenario definition, we could simply select the nodes that we want to restrain. However, we would need to reselect the nodes whenever the geometry or mesh changes. By investing a little time to create the geometry, we can create a model that automatically updates with changes. We load the wireframe and surface app. Then, from the Transform tab at the action bar, we select Extract. Select the hole on the right side of the lug and click OK. Then select Disassemble from the action bar. Click on the extracted surface and click OK. We will now repeat these same 2 steps for the hole on the left side. We will only need an edge for each side, so we will hide the geometry we don't need. The trailer loads are transmitted from the center of the ball to the face of the lug. Since we are not modeling the ball, we will create the geometry required to accurately apply the loads to the lug. First, we hide the lug geometry, and show the ball geometry. We will again use the extraction tool to create a dependent copy of the bottom face of the ball. We do this by keeping the link. To create a point at the center of the ball, we click on the Essentials tab located on the action bar. Then, we select Point and Circle/Sphere from the drop-down. We click on the spherical surface of the ball and click Yes to create the dependent copy of the geometry. We can now hide the ball geometry and show the lug geometry. We still need to perform some additional work to the surface that transmits the load to the face of the lug. So, we hide the two external reference surfaces. This allows us to more easily select the geometry located in the part body. Now, we are going to trim the surface used to transmit the load to the face of the lug. We need to do this before we can sew the surface. We click on the Transform tab and select Split. Then, we select the extracted surface from the model tree. We use the edge of the chamfer as the cutting element and select Other Side to create the desired geometry. Now, we can sew the surface that we just trimmed to the lug. This operation is necessary because in 3DEXPERIENCE, solids consist of faces and volumes. There is no means to split a face. So, we must perform a sew operation to merge the surface with the solid face. We launch the Simulation Model Prep app. Then, from the Idealize tab, on the action bar, we click on Sew Surface. We select the split surface from the model tree. Deselect Simplify Geometry, and click OK. This error simply means we have to flip the arrow. Click on the arrow to reverse it. Then, click on OK. The surface is now sewed to the face. We are now ready for step 3, creating the finite element mesh. To do that, we will insert a finite element model. In the tree, double-click on the lug part, then right-click it, and select Insert, Finite Element Model. Then, we scroll down to the finite element model, expand it, and double-click on Nodes and Elements. We want to create the mesh on the abstraction shape. Next, we will create a tetrahedral mesh. From the action bar, we click on Tetrahedron Mesh. We select the part body from the tree as the support. We verify that quadratic elements are selected, then initialize the mesh size from the geometry and click Mesh. We can see that this mesh is too coarse, especially around the holes. We set the mesh size to 9.5 and the sag to 0.25, and again click on Mesh. This looks much better. However, the mesh does not follow the geometry, where we want to apply restraints and loads. So, we will now constrain the mesh to the edges. First we hide the extracted surface, so we only see the sewed surface. Then, we click on Edit. The mesh does not follow blue-colored lines. However, we can click on the blue lines and constrain the mesh to them. Notice the mesh changed so it follows the line. The mesh visibility off, so it is easier to select the edges. When we are done defining the edge constraints, we make the mesh visible again. Notice, the mesh now follows all the key edges. We exit the meshing app, and click Yes, to update the mesh. Then, we update the model. We forgot to refine the mesh in the fillets. That is okay because it gives us the opportunity to demonstrate how to edit a mesh. We expand nodes and elements. Then, right-click on the mesh and edit the mesh object. We will create a local mesh specification. For supports, we will select all of the fillet radii. The size of 0.5 mm is acceptable, so we click OK. Then we click on Mesh. And OK. Finally, we update the model. Now, we can define the mesh properties. On the action bar, we switch from Mesh to Model. Then on the Properties tab, we select Solid section. For support, we select the part body from the tree. After changing the name, we click on OK. Let's update the model. The mesh is now completely defined. However, we still need to create a proximity group so the restraint on the pinhole will automatically update if we make changes to the geometry or the mesh. Click on the Group tab in the action bar. Before creating our proximity group, we will turn off the solid geometry. This will make it easier to select the edges. Click on Proximity Group. Then select the edges. We change the name, and then click on OK. Here is the group that we created. Now, we can update the model one last time. Here are the nodes associated with the proximity group. We will be able to define a restraint using this group. The model definition is nearly complete. However, we also want to create some publications. These publications will make it easier to prescribe the other loads and restraints during creation of the simulation scenario. Publications also can be used to request specific output for specific regions of our finite element model. We start by hiding the mesh so it is easier to select the geometry. And we make sure the solid and the sewed surface are visible. Then, we double-click on the part. This transfers us to the Product Structure app. On the action bar we click on the Product Edition tab. We then click on Publication, and select the left edge, where the adjustment bar contacts the log. Then we change the name, and click on OK. We repeat this process for the other key geometric features. Notice, the publications are at the same level in the model tree as the FEM-rep. The model definition is now complete, and we are ready to progress to creating a scenario.